Okay, as we wrap up section 7.1, that last video was just getting a little too long. There's only one page left here, but oh well. Simplifying variable expressions, okay? Simplify variable expressions. Okay, we're going to use the little phrase combine like terms. Okay, combine like terms. Okay, a like term. Now, what do we mean by like terms? Well, like terms have an exact matching variable. Okay, coefficients do not need to match. Okay, so we're looking for a matching of the letter part. Okay, the number out front doesn't have to match. It can match, but it doesn't have to. But the letter part must be an exact match. And if so, we're just going to put them together. Okay, we're going to by adding or subtracting those coefficients. All right, if we take a look here at example 9 on page 321, part A. 5a plus 2a minus a. Okay, I'm just going to put those things together. I've got 5 apples, I'm going to add 2 apples to it, and then I'm going to take 1 apple away. How many apples are left? We know how to do this. 5a plus 2a is going to be 7a, but then 7a minus an a is going to be 6a. Combine like terms. They all had to be matching a's, and they were. I can simply add and subtract and combine them. Okay, part B. 3x plus 5y plus 8 minus 2x plus y minus 12. Now I've got 3 different things at work here. I've got x's, I've got y's, and I've got regular constants. Okay? Like terms mean the x's are going to be put together with the other x's. The y's with the other y's and the constants with the other constants. So I've got a 3x minus a 2x there, right? I can just, here's where I try to make the argument to not go through and do all those changes to add the opposite. You can, okay, and I understand this is new to you. Okay, but to me this is an unnecessary clunky step here, because now it's plus negative 2 instead of minus 2x. And now it's plus negative 12 instead of minus 12, okay? But once we have that form of it's all additions, that's why we did that, it's all additions, okay? Well, now if you want, you can physically shuffle stuff around and put the x's side by side and the y's side by side and the constants side by side if you wanted to. Okay, you don't have to physically move them, you just got to put them together in your mind. I've got a 3x and a negative 2x I'm going to put together, that'll give me a 1x. I've got a 5y and then just another y, which means 1y, so that'll give me a 6y. And I've got an 8 and a negative 12 that I'm trying to put together, and that'll give me a negative 4. Okay? Everybody cool with that one? So x plus 6y minus 4, you do not need to write that 1 in front of the x. You can. I'll never tell you not to, but you don't have to. Okay? Alright, example 10 is going to trick it up now with the distributive property. Okay, and then we're going to combine like terms. So A says 3 times 5x minus 2. Okay? We're going to take the 3 times the 5x and give me a 15x. And again, now we can either think of it as bringing down the minus, and then it's going to be 3 times a positive 2 gives me a positive 6, like that. Or think of that as just a negative 2. 3 times negative 2, and then write it down as negative 6. Okay? Now, how do I I combine these two terms? How do I go farther? I don't, right? Because they're not like terms. An x term and a constant term can't be put together. So we're done. We got it. Okay, let me sneak b in over here on this page. Negative 7 now, okay? X plus y minus 3z. We are distributing a negative 7 across. And here's another reason why I don't like this rewriting stuff. Negative 7 times positive x is negative 7x. Negative 7 times positive y is negative 7y. Okay, and then I want to think of that, instead of thinking that as minus a positive 3z, that's really plus a negative 3z. That's a negative 3z in my mind. And if I take a negative 7 times a negative 3z, negative times negative gives me positive 21z. Okay? I like it. Part C of example 10. For some reason, this really bothers students. Example 10, part C. I don't know why. I haven't figured out why. This should be really easy. If I just have a negative in front of a parentheses, that's it. Well, I want to take the opposite of everything in that parentheses. That's what a negative sign is doing. It's taking the opposite. So what's the opposite of negative 3? Positive 3. What's the opposite of positive 4? Negative 4. It just changes the sign of everything inside that parentheses. Okay, that's all it's doing. Another way to think about it, okay? Think of it as a negative 1 out there. And now you have to do a distributive process and distribute that negative 1 across. So it's negative 1 times negative 3x gives me a positive 3x. And it's negative 1 times positive 4 gives me negative 4. Okay? Two ways to think about it, ultimately the same result. Everything inside that parentheses got a change in sign. Okay, that's it for 7.1. Okay, 7.2 on page 323 actually starts solving equations. Okay, now it's our job to find x, and it's going to be an equation. These, of course, are expressions, right? There's no equal signs. If I asked you to take this right here and solve for x, tell me what x is, you can't do it because there's no equation there. Okay, you can't do it. So if anybody ever asks you to solve something without an equal sign, tell them to go fish. It can't be done. Okay? The best thing that could be done is what's called, this is not in the book here right now, but it probably shows up somewhere, but I'm going to throw it in right now. Evaluate the expression. Okay, and I did mention this in that other video too, right? Evaluate an expression. That's an expression. And if I want you to boil it down to just a value, I don't want 3x minus 4, just give me a number. Well, that requires me to tell you what x is. Okay, so I'm going to say x equals 5. Okay, I had to tell you that. Now you can tell me what is 3x minus 4 by putting the 5 now in place of that x. So remember, it's a relationship of multiplication. It's 3 times x, so I need to do 3 times 5. I need to put some kind of time symbol in there. Minus 4, so it'll be 15 minus 4. So we'll get 11 for the value of that expression. Okay, but somebody had to give us that value of 5. We couldn't find it ourselves. And they could have given us any value, right? I just pulled 5 right out of the air. I could have pulled anything out of the air. I could do the same trick and say x is negative 10. Now let's do it. 3x minus 4 means 3 times negative 10 minus 4. So that's going to be a negative 30 minus 4, a negative 34, okay? Depending on what value of x is given, you're going to have a different value for your expression. But the choice that x was 5 or the choice that x was negative 10, there's no right or wrong to that choice. It's just something that's given to us. Okay? there's no right or wrong with the choice of x for an expression. But for an equation, there is a right or wrong. Okay, for an equation, the types of equations we're going to look at right now are what's called linear equations. Of one variable. Okay, in linear equations of one variable, there's a couple exceptions to what I'm about to say, but for the most part, linear equations of one variable have exactly one solution. One solution. Okay? Here our choices for x were infinite. I could have told you x is anything, and you could have put it in there and cranked out a number. With an equation, not so. There is one choice for x, and it's going to be our job to find that one choice. Oh, I'm still zoomed in. That's why it's not working. See what I get for zooming in? Okay. All good. Let's turn our attention, please, to page 323. One of the best ways to think of an equation is a balance, okay? So there's little balance scales there. You see this first scale's got 1 ounce on each side, and it's nice and balanced, right? The second equation says, hey, I removed half an ounce from one side only. Well, of course, it's out of balance. But then I went ahead and removed a half an ounce from the other side, and it's back in balance again. And that's the techniques we're going to be using to solve these equations. We're going to add things, we're going to remove things, we're going to multiply, we're going to divide, but we're always going to do the exact same thing to both sides of our balance in order for it to remain balanced. Okay, the equation is just like a balance. Think of an equal sign right in place of that little balance pivot point there. There's an equal sign there. The stuff on the left equals the stuff on the right. Okay, and if we want to make a change like yanking off a half an ounce on the one side, we better make the same change and yank out half an ounce on the other side, otherwise it won't be balanced anymore. Okay, and you're going to see how we do that. All right, nice. Let's do it. Top of 324. To solve a linear equation using the addition axiom. Okay, now there's some kind of formally stated properties here, but you'll see it's real easy. Locate the variable in the equation. So find x, okay, got it. Identify the constant that's associated with the variable by addition or subtraction, okay. Add the opposite of the constant to both sides. It always sounds like such a formal, difficult process here. Let's look at it. X plus 4 equals 8. That's my equation. Okay. Now this is the kind of equation we could just solve it by common sense, really, right? Without even thinking of ourselves as math students here, right? I've got some number, it's a mystery, I don't know what it is, but if I add 4 more to that mystery number, I'm going to get 8 altogether, right? So we know the answer is 4, right? We know. But how do you get there? Well, think of this equation as a balance, okay? And my goal is to get x all by itself on one side of that balance. Okay, so I want to work my magic here, and I want to just have x left on the left, and then the equal sign right after x, and then some number over here, right? And that's going to be the answer, that number. That's what I want, okay, and it's got to be a 1x. Now, of course, this one already is a 1x. I just don't see the 1 there. Okay, so I need to remove obstacles that prevent me from having this x equals number. That's what I want. Give me x equals number. Well, there's a plus 4 in the way. Okay? Now, if my goal is x equal number, I think you would all agree if I had x plus 0 equals number, that's just as good as x equals number, right? Because plus 0 is not hurting anybody. So I'm close. I've got an x plus 4 equals number. I just need to have an x plus 0 equals number. So I need to turn that 4 into a 0. And I can turn a 4 into a 0 by subtracting 4 away from it. Right? So I just removed a block from one side of that old balance beam there, just like in the picture. And you know now it's going to be out of balance unless I remove the same size block from the other side. So I have to subtract 4 from both sides. Okay, well now I've just got x, and I'll go ahead and write it just this one time. 4 minus 4 we know is 0, so x plus 0 equals some number. I got to figure out that number. It's 4. And then we, of course, just drop the plus 0, and we say x equals 4. Okay, that's how we're going to solve these problems. Eliminate all obstacles in the way of 1x equals number, and then that's the answer, because I'm looking for x. Alright, let's do it. Example 2 says, let me get a fresh page. Example 2. Part A says, this is page 324, x plus 3 equals 8. Okay? Again, some unknown magical mystery number plus 3 more equals 8 altogether. If I want to find that number, I need to eliminate this 3. I'm going to subtract it away. So now I just have the x, that's 0, I won't write the 0. X all by itself equals some number over here, and that's my answer. X equals 5. Alright, the beauty of any equation, though, is that you can check your answer. Now, I'm not going to take the time to check these. Just this once. Check. How do you do it? Go back to your original equation, and now we're just going to ask a question. If I put the 5 in place of the x here, because I claim x equals 5, so let me put it in there, I better get a true statement here. If I don't get a true statement here, then something's wrong. Okay, and you see, I get a true statement there. It doesn't matter what the statement is. Okay, 8 has nothing to do with it. It just has to match. The answer is not 8. The answer is 5. That's just a check. I need a true statement, and I got it. If I get a false statement here, something's wrong. Either I made a mistake in my calculation for x, or, unfortunately, we could have done a great job here, and then we screwed it up as we tried to check it. Okay, so there's a mistake somewhere. I'm just not sure where. Okay, example 2, part B here. Okay, now this one's slightly different. I've got a minus sign in here now. X minus 2 equals 4. Okay? I need to undo a minus 2. How am I going to undo a minus 2? I want to turn a minus 2 into a 0. So in this case now, I need to add 2 to both sides. Okay, so let me pause there and reflect a minute. Up here I subtracted 3 from both sides because I had a positive 3, and if I put a negative 3 with it, it makes it go to 0, and that's what I wanted. I wanted it to be gone. Well, here it's already negative 2, so now I'm going to put a positive 2 with it and make it go to 0. Gone. Now I've got x all by itself. I have to figure out what it is over here. X equals 6. Okay, part C. 5 plus x equals 2. Now, wait a minute. It's written a little bit different, right? It's 5 plus x instead of x plus 5. Does that matter? No, it doesn't matter. Okay? With the commutative property, if we really felt like it, we could reverse position of these two things. If it makes us feel better, we could write it that way. Okay, I'm going to go back and not, because we don't have to. Okay, so let's try to get comfortable not having to. Okay, x is there, it's fine, nobody's hurting it. It's got a plus 5 here on the same side, so if I subtract the 5 away from both sides, 5 minus 5, gone. The only thing left over here is x and an equal sign, and that's what I want. Again, 1x, which is crucial, and we'll get to the point where we don't have 1x, but right now we do. Well, I got to do this over here now. 2 minus 5, negative 3. X equals negative 3. Okay. All good there? The last part of example 2 part D, even tricks it up a little bit more, maybe out of our comfort zone. Now x is over there on the right. Oh man, what are we going to do? We're used to having x on the left, and now we got it on the right. Well, again, I don't want to get in the habit of doing this, but we could simply reverse the whole thing. Put the x minus 1 on this side and put the 10 on that side if it makes us more comfortable. But again, I don't want to get in the habit of doing that because it's truly unnecessary to do that. Okay, so let me put it back. I need x equals number, right? That's my goal. X equals number. Well, if I have number equals x, that's the same thing, so I'm going to get number equals x this time. Alright, so let me examine how I can get x all alone over here on the right. Well, I got this pesky minus 1 bothering me. So if I add 1 to both sides, the minus 1 and the plus 1 go to 0. Sometimes we kind of cancel them out. I haven't been doing that, but sometimes we kind of cancel it out and say it's gone now. It's a 0. Over here I'm going to have an 11 equals x. Okay? There we go. So that's using addition and subtraction now to remove these obstacles. I had an obstacle of a positive 3, a negative 2, a positive 5, a negative 1. I got rid of all those obstacles, and in each case I had x equal number left over, and that's my goal, x equal number. Okay, let me pause it here, and I'll continue on the next video.